Hi, and welcome to the Screencast, The Changing Earth 1.2. Before we begin, please make sure that you have your notes set up in Cornell note fashion, that you have today's title and today's date at the top of your page. Now, last time we talked, we learned that there were 4 layers to Earth, and that the thinnest layer, the outside layer, was called the crust, and that the crust was made up of tectonic plates. Well, today we're going to be talking about how those plates change positions over time. Alfred Wegener was a scientist who proposed a hypothesis in 1912 known as continental drift. Now, continental drift is the idea that the Earth's continents were once joined in a single landmass. In other words, all of the continents were one big giant continent, and it was called Pangaea. And Alfred Wegener believed that at one point all the continents were together, and gradually they drifted apart to where they are today. You see the picture here of Alfred Wegener, and we're going to watch a short video on how his idea came to be.
Germany, 1911. A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa, and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaea, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. Continental drift was just too incredible to believe. As a result, his discovery was largely ignored.
Alright, so now you have a little bit of a backstory of how Alfred Wegener came up with this hypothesis of continental drift. Now remember that the word hypothesis means an educated guess. So based on the evidence that he found in the books and what he found when he traveled around the world, this is what his educated guess about continental drift was. All right, let's look at what the continents looked like when they were part of Pangaea. So Pangaea, again, is the joining of all the continents into a huge supercontinent. You can see how they were all lined up, all in one place on Earth, and that it reached from pole to pole, from the North Pole all the way to the South Pole. And it's centered where Africa actually is today. All right, let's look at the evidence that Wagner used to support his hypothesis of continental drift. His first piece of evidence was the fossil evidence of the Mesosaurus, which was discovered in both South America, on the eastern edge of South America, and the western edge of Africa. And the only way that these two fossils could be on those coasts was if both those coasts were originally together. So that was his first piece of evidence, was that both of those continents were close to each other or once joined. And again, this is where, right in here between South America and Africa, is where they found the Mesosaurus. Now, other scientists had their own explanation of how these fossils came to be on both sides of those continents, and they were pretty far-fetched. In the first picture, they thought that the animals simply hopped on a piece of driftwood and floated across the ocean. Now remember that this is thousands of miles of ocean, and so that's not a very likely scenario. The second picture says that they walked along land bridges. So the scientists thought, well, maybe those two continents were connected with a huge piece of land, and the animals just walked across. The third one, and my personal favorite, is that they jumped from island to island until they got across the ocean. Boing, 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 boing. Or they simply swam across that large ocean. But Wagner's hypothesis, the very last picture, kind of made a little bit more sense. And I don't know if you can see, but here there's a dinosaur on this side with probably the mama's heartbreaking, and on the other side is the family. Oh, bye, Mom. It didn't really happen like that, but you get the idea. His second piece of evidence was looking at how the climate changed. So Wagner was actually originally a meteorologist. He studied weather. And so what he found was that there was evidence of changes in climate that happened in places that weren't very likely. So, for example, in Greenland, which is north of where Canada is, which is towards the North Pole, is covered in ice, right? Right now it's covered in ice and it's frozen. And yet he found fossils of tropical plants, the Glossoropterus. Okay, and in South Africa, which is, close to the equator right now, and is very warm, they actually found evidence that the rocks were scratched by ice sheets. Well, the only way here, and here we have a picture that demonstrates that. So the white here, down below, shows where they found evidence of ice. Okay, the upper picture here shows where the continents are now, and the equator is kind of right in here. Okay, so obviously, in order for there to be ice in the areas where there's now an equator and it's warm, these continents had to be together. His third piece of evidence, and the best evidence for him, was that it came from the study of geology, which is the study of rocks. And when we start learning about rocks, which we will do later in the semester, you find out that certain rocks are made in a certain way, and they don't just happen anywhere. So what he found was that there were similar rocks found in Brazil and in Western Africa, the granite that you see down on the left-hand side, okay, that was similar on those coasts. And they also found limestone in North America and the highlands of Scotland. Okay, so here we have the western coast of Africa and South America, and this is the areas that they have rocks in common. So you can see right along those edges of those continents how it has similar rocks. Okay, here's there and there. And so that doesn't happen by accident. Okay, they had to be close to each other in order for those formations to occur. So Wagner's hypothesis was not accepted at first. Even though he had all of this evidence and it all made a lot of sense, and he could show that the continents moved, he couldn't do one thing, and that was he couldn't explain how these continents moved. I mean, how in the world can these huge slabs of rock move across the ocean like that, even if it's over hundreds of millions of years? And so because of that, his hypothesis was not really accepted until about 30 years later, when evidence of how the continents moved came about. Unfortunately, he died on one of his expeditions 30 years before we actually got to accept his hypothesis. So here is a very silly song that I found about Alfred Wegener. Kind of tells a little bit about his life and about his adventures and about his hypothesis. This would be, making up a song would be a great thing to add to your e-portfolio and show me that you understand all the concepts that we learned about. Okay? All right. When you're finished watching the video, then please go to the virtual classroom to take a short quiz on this presentation. And again, that's going to be under Changing Earth, Plate Tectonics, Changing Earth 1.2. All right, here is our video.
There was a scientist whose name was Alfred Wegener. He noticed that the continents looked just like pieces of a broken puzzle. By 1915 he called it continental drift. It caused a rift with his fellow scientists who sang, Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. They reminded him he had no proof for how or why the continents could do this. And until you show just how or why, you merely have one interesting hypothesis. Until this evidence we see, you don't have a theory. Alfred Wegener, you are a crazy man. Alfred Wegener, you are a crazy little man. In the year of 1930, on an expedition to Greenland, Wegener got caught in a blizzard. When they finally found him, it was much too late, and they buried him in an icy mausoleum.